Questions 11 through 20 on the 2003 Grade 7 Gauss Math Contest. If 1/2 of 2/3 of the 12 small squares in the given figure are removed, how many squares remain? So we have 12 squares, and let's just concentrate on the 2/3. 2/3 of those would be 2/3 times 12, which is 24 over 3, which is 8. And then they're saying 1/2 of that. So 1/2 of 8, which is 8 over 2, of course, which is 4. So 4 are how many are removed. So how many remain? Well, initially you had 12. 4 are removed, and therefore 8 remain. So number 11, the answer is D. The perimeter of a rectangular field is 3 times its length. If the perimeter is 240, the width of the field is. So perimeter is equal to 3 times the length. And if you have a rectangle of any sort, we know that if this is the width, this is the width, this is length, and that is length, perimeter is 2L plus 2W. But we are told that the perimeter is 3L, so 3L goes here. We've got 2L plus 2W. Bring the 2L to one side, and that just leaves L as 2W. Now the perimeter they told you was 240. So if the perimeter is 240, that means 240 is equal to 3L. L is equal to 240 divided by 3, which is 80. So now bring that 80, put it here. 80 is equal to 2W, and therefore W is equal to 40. So 12, the answer is B. Chris and Pat go on 30-kilometer run together, and they both usually run at 10 kilometers per hour. If Chris runs at half his usual running speed and Pat runs at 1.5 times her usual speed, how many more hours does it take Chris to complete the run than it takes Pat to complete the run? So our formula is speed is equal to distance over time. And any combination or variation of this formula also will work. For example, time is equal to distance over speed, and so on. Now Chris, C for Chris, he normally runs at 10 kilometers an hour, and now he's running at half his usual speed, so he's going to be running at 5 kilometers per hour. And he's going to be going on a 30-kilometer run. So we want to figure out the time. Time is equal to distance over speed. So that means distance in this case is 30, speed is 5, and therefore this is 6. 6 what? 6 hours. So that's an awfully long run for Chris. Now Pat is running at 1.5 times her usual speed. Her usual speed is also 10. So 1.5 times that is 15. 15 kilometers per hour is what she will run now. Her distance is 30 kilometers, so we have to figure out her time. Time for her is distance over speed, so 30 over 15, which is 2. 2 hours. So they want you to figure out how many more hours does it take Chris to complete the run than Pat. Takes Chris 6 hours, takes Pat 2 hours, so 6 minus 2, which is 4, is how many more hours it takes Chris to complete the run. So number 13, the answer is D. A box contains 14 discs, each colored red, blue, and green. There are twice as many red discs as green discs and half as many blue as green. How many discs are green? So there are twice as many red discs as green. So R is equal to 2G. Half as many blue as green. So that means green is equal to 2B, like that. And they tell you that the total is 14. So R plus B plus G is 14. So what we can do is just substitute all these into here, our main formula. So for R, I'll put 2G right here. B, I'll put G over 2 from here. And then G I can just leave alone since that's the variable I need to figure out the value for. So adding this together, let's see, we'll multiply through by 2, get rid of the fraction. 4G plus G plus 2G is equal to 28. So this looks like 7G is 28, and therefore G is equal to 4. So there's 4 green discs. So number 14, the answer is B. A bottle of children's vitamins contains tablets in 3 different shapes. Among the vitamins, there are 60 squares, 60 triangles, and 60 stars. Each shape comes in an equal number of 3 different flavors, strawberry, grape, and orange. A tablet is randomly chosen from a newly opened bottle. What is the probability that this tablet is a grape star? So we've got 60 squares, we've got 60 triangles, and we've got 60 stars. Okay. And each shape has an equal number of flavors, strawberry, grape, and orange. So that means these squares have an equal number of strawberry, grape, and orange. And very similarly, the triangles have an equal number of strawberry, grape, and orange, and as do the stars. So if there's 60 squares, and there's an equal number of strawberry, grape, and orange, each of those, there's 20 of them. And the exact same thing holds true for the triangles and for the stars. So they want you to find how many are grape stars. So grape stars right here. They're grape and then they're stars. So probability. So there's 20 grape stars. And in a probability question, you divide by the total. The total is 60 plus 60 plus 60, which is 180. So this is the probability. In lowest terms, that would be 1 over 9. So 15, answer is A. A triangle ABC has vertices at 2, 0, 6, 0, and 6, 3. The area of the triangle in square units is. So we can plot this. Let's see here. We've got 2, 0, so 1, 2 right there. That's our first point. We've got 6, 0, so 3, 4, 5, 6. There's our second point. And 6, 3, so 1, 2, 3. So approximately here, 6, 3. And then this is a triangle that they are saying we need to figure out the area of. Okay, no problem. So the first thing you'll notice that this is a right triangle. The distance from here to here is 3. The distance from here to here is 6 minus 2, which is 4. And therefore the area of this triangle is 1/2 base times height. 1/2 base, which is 4, times height, which is 3. So 12 divided by 2 is 6. So 16, the answer is C. Jenna rents a car for a business trip. The rental company charges a fee of $45 plus 12 cents per kilometer driven. If Jenna's bill before taxes is $74.16, how many kilometers did she travel in the car? So her fee is $45 plus 12 cents for each kilometer, K. And her total bill was $74.16. So we are solving for K, as K represents the number of kilometers. So 0.12 K is going to be 74.16 minus 45, and therefore this looks like 29.16, 0.12 K, and therefore K will be 29.16 divided by 0.12, and that will give you a value for K of 243. kilometers. So number 17, the answer is C. Two squares, each with side length 5, overlap as shown. The shape of their overlap is a square, which has an area of 4 centimeters. What is the perimeter in centimeters of the shaded figure? So these are squares with side length 5, so that's 5, that's 5. And this little guy right here that they are calling the overlap, it's a square, and they tell you it has an area of 4. So if a square has an area of 4, that means its side lengths are 2. So this is 2, this is 2, that's 2, and that's 2. So now we can figure out this side length. If this is 5 and this is 2, that means that's 3. And in a very similar way, that's 3, this is 3, and this is 3. Okay, so the perimeter of this shape will be 5 plus 5, which is 10, 5 plus 5, which is another 10, then this 3 and this 3, which is 6, and finally this 3 and that 3, which is another 6. So this looks like 20 plus 12, which is 32. Perimeter of the shaded figure. So 18, the answer is B. Abraham's mathematics exam has 30 algebra questions and 50 geometry questions, each worth 1 mark. He got 70% of the algebra questions correct, and his overall exam mark was 80%. How many geometry questions did he answer correctly? So his algebra questions, the ones he got correct, plus the geometry questions, divided by the total number of questions, which is 80, 30 plus 50, gives him a mark of 80%, because his overall grade is 80%. Now, this is pretty much the equation. So A plus G is equal to 0.8, because 80% is 0.8 over 80. So A plus G is equal to 0.8 times 80, and 0.8 times 80 is 64, is equal to A plus G. Now, he got 70% of his algebra questions correct. There's 30 algebra questions, and he got 70% of them correct. So 0.7, which is 70%, times 30, gives you 21. That's how many algebra questions he got correct. So this is 21, and 21 plus G is equal to 64. So G is 64 minus 21, which is 43. So he answered 43 geometry questions correctly. So 19, the answer is A. Six points A, B, C, D, E, and F are placed on a grid as shown. How many triangles that are not right-angled can be drawn by using 3 of these 6 points as vertices? So this is one of those questions where you just have to kind of go through this and see what we can figure out. Okay, no problem. Let's see, I've got one triangle like that. So whatever I draw a triangle, I'll draw it over here, because otherwise when I keep erasing them, they'll get a little messy. So this first triangle looks kind of like this, right? So I'll save it over here. Is it good or bad? Well, unfortunately, this one is no good because they have this rule that it cannot be a right triangle. All right, no problem. Let's just keep going here. How about something like this? Again, I'll draw it over here. I'll save these so we can compare them later. Well, unfortunately, for the same reason, no good, because it's a right triangle. You see what I mean? It's just a trial and error, basically. So same kind of story. You have to go through these. And in a very similar way, this guy is the same as this guy here. Another triangle using those types of vertices will be the same as this right here. So let's see if I can get something different. How about this one right here? That one. perhaps that will be different. Well, unfortunately, this is also a right triangle. Right here, this is a right triangle. Right there. And I know it's not as obvious, but if you look at the fact that these are equidistant, right? This is going to be the same distance from here to here. Then from here to here is the same, right? You'll be able to figure that out, that that's a right angle. So no good there. Okay, no problem. Let's keep going. Eventually we have to figure out some of them, unless the answer is 0, and 0 is one of the answer choices. How about this one here? Right there, there, and then there. Those ones. That one is certainly not a right triangle. So I think that is something that will work. So I'm going to keep that one. And in a very similar way, I draw it again, and I'll keep that one also, so I'll put that over here. And I'm going to label these so that I know which ones I have. This one that I just drew is B, C, and D, and the first one was A, B, and F. Okay? I think I've got a few more that I could probably figure out using the bottom there. How about this one here? This one would work. So that would mean like that. And these vertices are D, E, and C. And I think I can get one more based on the symmetry of this diagram right here. That one. So I think that's it. Not exactly drawn to scale, but that's okay. A, E, and F. So I think these are the ones, the A, B, F, B, C, D, C, E, D, and A, E, F. These are the triangles that are not right triangles that I can get using 3 of these vertices. So I found 4 of them, and therefore 20, the answer is E. Now all the other ones that you'll find are unfortunately going to get this right angle, and therefore that does not satisfy the conditions of the question stem.